Alright, my math friends, here we are, chapter 13, the very last chapter of the book. Okay, so my very last set of video lessons that I'm going to be making for you this year for this book. So let's take a look at what we have. We're still going to be working with probability, but we're going to be working with this thing called theoretical probability. Okay, and we're going to jump right into some compound events because we talked about that already in chapter 12. Here's what we have. Chapter 12 was experimental probability. This is what actually happened. Okay, we calculated the probability of some experiments and some other things. That is what actually took place. Okay, theoretical probability is what we predict will happen. Okay, this is what we think will happen, where chapter 12 is what actually happened. Okay, so there's some different steps we're going to do. It's still going to be probability, but it's going to be just a little bit different. Let's take a look at what we have here. Here's example 1. The first thing we're going to work out. You have 2 dice. What is the probability of rolling both the dice so that the sum of the numbers is equal to 6? Okay, so if you roll these dice, we want to know what's the chances of these numbers being equal to 6. Okay, in chapter 12 we would have actually rolled the dice and figured that out. Chapter 13, we're not going to roll the dice. We're going to predict what this would be. Okay, this is what we're going to try and find out. We're going to predict what the chances would be. So we're still going to calculate probability. So remember, probability is how many of something on top of the fraction over the total possible. Okay, so that's what we're going to find out. We're going to find out how many, and we're going to find out the total possible so that we can answer this question. Okay, step number 1. We're going to make a table to find all possible outcomes. Okay, we want to find out all the possible ways that we could roll this dice. Okay, that's what we want to know. We need to find out what all the possible ways are of rolling this dice. Okay, so here's what we're going to do. We're looking for the sum of the numbers to be 6. Okay, so I'm going to label this first box here sum, because that's what it is that we're going to be looking at. And on the top here, we're going to have dice number 1, and then along the side here, we're going to have dice number 2. Okay, so on dice number 1, you could roll a 1, a 2, a 3, a 4, a 5, or a 6. And dice number 2, you could roll a 1, a 2, a 3, a 4, a 5, or a 6. So what this chart is going to do is, this is all the possible ways that we could roll the dice. For example, dice number 1, we could roll a 4. Dice number 2 could be a 2. Another time we roll, for example, dice number 1 could be a 2, and dice number 2 could be a 5. Okay, it's all the different possibilities we can get when we roll this dice together. And in the middle here is going to be the sums of all the possible outcomes. Like, for example, if we roll a 1 and a 1, that's going to add up to a 2. If we roll a 1 and a 2, that's going to get us a 3. If we roll a 1 and a 3, it's going to get us a 4. A 1 and a 4 will give us a 5. A 1 and a 5 is going to get us a 6. And a 1 and a 6 would get us a 7. Okay? So we would move on to the next column and find the sums of all these possible choices. If dice number 1 rolls a 2, and dice number 1 rolls, or dice number 2 rolls a 1, that's going to get us a sum of 3. And then we'd have, if we got 2s and 2s on both of them, it would get 4. And so on. So I'm going to fill out this table. I'm going to let you guys do the same thing, and I'm going to pause the video, and then I will hit play again when I get this filled out, and then we'll talk about what to do next. So you guys do the same thing. I will do the same thing in the meantime, and then we will work on this next part together. Alright, so there's my table completely filled out. As you guys were working this, you probably saw some patterns that made it go a whole lot faster. But here is all the possible outcomes you could get by rolling the two dice and all the possible numbers you get if you added them together and got the sum. Okay, so we did step number 1, find all possible outcomes. Okay, so the number of outcomes, the total possible, that's what we're looking for. The number of outcomes, if you count up each one of these boxes, okay, you get 36 outcomes total. Okay, that's all the different options we could get if we roll the two dice. We could have 36 possible outcomes. Okay, so that's going to be our total possible. Now we're going to find the number of, we'll call it desired outcomes, what we want. And what we're looking for is this right here, the how many that we have. So we need to find out the desired outcomes for a number that is equal to 6. So we have 1, 2, 3, 4, 5. Okay, so there are 5 desired outcomes. Okay, so we had 36 total possible outcomes, and then we have 5 desired outcomes that would give us a sum of 6, all the ones we circled. So now, step number 3, we're going to determine probability. Okay, so what does this tell us about our chances of rolling a sum of 6? Well, if we make that into a fraction, we would have 5 out of 36 chance of rolling a 6. Okay, and if we make that into a percentage, if we divide 5 divided by 36, alright, if we do the math on that, that would get us a percentage. And that would round up to 0.14, which we can move the decimal 2 places, and you could say 14%. Okay, so that would be our theoretical probability. That's what we predict is going to happen. You have a 5 out of 36 chance of getting a sum of 6, or you could say it's a 14% chance of rolling a 6. Alright, so there's theoretical probability. If you don't like to make a table, we're going to look at another way that we can also look at theoretical probability, and we can use something called a tree diagram. Alright, so how the tree diagram would work, let's take a look at this situation. A deli prepares sandwiches with one type of bread, white or wheat. Okay, one type of meat, you can go with ham, turkey, or chicken, and one type of cheese, which can be cheddar or Swiss. Each combination is equally likely. So someone could pick wheat bread with turkey and cheddar. Okay, they have an equal chance of picking any of those. Find the probability of choosing a sandwich at random and getting turkey and Swiss on wheat bread. Okay, so that's what we are looking for, is the turkey and Swiss on wheat bread. So the first thing we're going to do, step number 1, just like we did in the table, except this time we're going to use a tree diagram to find all possible outcomes. Okay, all possible choices is what we are looking at. Alright, so we're going to start this tree diagram, and here's how it's going to work. So let's start with, it's a sandwich, that's what we're working with. Alright, so we have a sandwich, and then we're going to break this sandwich into a tree diagram. So my first choices I have is white or wheat. Okay, so I'm going to break this into 2 separate things. So I'm starting with the sandwich, and I could go with white bread, or I could go with wheat bread. Okay, it's kind of like a flow chart here that we were talking about at the beginning of the semester for our flipped classroom. So you pick your sandwich, you can have white or wheat bread. Then your next choice that you can have is you could have ham, turkey, or chicken. So on white bread, I'm going to make 3 lines, and I'm going to say ham, turkey, or chicken. Same with my wheat bread. I could go with a wheat sandwich that has ham, turkey, or chicken. Okay, so there's my possible choices so far. For white bread, I could have this, I could have wheat bread with this, and then on top of that, you could also pick a cheese, cheddar or Swiss. So I could have white bread with ham, and I could choose either cheddar or Swiss. I could have white bread with turkey, that could be cheddar or Swiss, or I could have white bread with chicken, that could be cheddar or Swiss. Alright, now let's take a look at our possible options for wheat. Kind of running out of space here, but I could have ham, cheddar or Swiss, turkey, cheddar or Swiss, or chicken. Could be cheddar or Swiss. And that is all my options. I've listed all my options here. Okay, I got to the end of it because the last thing was the cheese. So now if we count up each one of these, this will tell us our total possible outcomes, our total choices for sandwiches. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 possible choices. Okay, 12 possible outcomes. Alright, so that's going to be the number on the bottom of our probability fraction. Now let's find the number of desired outcomes. Okay, so if we trace this tree diagram, we're looking for wheat bread, turkey, and Swiss. So if we follow this, here's our sandwich. We need wheat bread. It's going to follow down the path of turkey, and it's going to follow down the path of Swiss. So there's actually only just one choice for that. I mean, there's one option. So our desired outcome is just one sandwich that comes out to these different choices. So now we can determine the probability. So getting a sandwich with wheat bread, turkey, and Swiss, you have a 1 out of 12 possible choices for our probability. And if we make that into a percent, we can take 1 divided by 12. And when we do that, that'll tell us what percentage it would be. And it comes out to 0.08. And we can move that decimal point 2 places over to make it 8%. Okay, so the probability of picking that type of sandwich, a wheat bread with turkey and Swiss from this deli at random, would be a 1 in 12 chance or an 8% chance of getting that sandwich. Alright, so there's your example for using some theoretical probability on compound events. You guys can use a table, you can use a tree diagram, whatever it is that you would like to use more. Don't forget to try this problem. I'll see you guys next time in class, and we'll work some more of these out together. Thank you for watching.